Teams to your battle positions. Tonight, 6 more schools compete in the semi-finals to solve real-world problems. It has been a tough journey, but which 2 schools will pull through to the Grand Finals? Hold your breath and cross your fingers. It's time for the National STEM Championship.
Please, someone help me. Freeze!
Welcome to the National STEM Championship. I'm Sonia Chu. 12 schools compete in the semi-finals across 4 different locations. And tonight, we're moving to the next 2 locations where semi-finals 3 and 4 will be held. Now, teams with the most amount of points will move on to the next round in the Grand Finals. So let's kick it off by getting to know the teams from semi-final 3. Let's give a big welcome to Raffles Girls' School, St. Joseph's Institution, Sinmin Secondary School. These teams will be pitted against one another and their battleground, Nanyang Technological University. NTU prides itself in being research intensive and they've got over 33,000 students across 6 colleges. And guess what? The college in engineering is actually one of the largest cohorts. So that kind of sets some expectations for tonight. Let's find out more.
A very warm welcome to NTU. I'm Ping Feng. I'm Assistant Professor within the School of Mechanical and Aerospace Engineering. Without further delays, I think we can start off today's challenge.
Our teams were wowed by the various innovative technologies they saw. 3D printed carbon fiber cars were designed and built as prototypes to address engineering problems. Students also observed a robot 3D printing of cement, which constructed a restroom. With their jaws appropriately dropped, it's time now for the challenge.
I'd like to tell you more about the challenge you are facing today. So we're going to talk about a car crash. We are in a car and the car is traveling at some speed and opposite is coming another car. You're going to have an impact. So how do you protect the occupants in the car? We are going to ask you to design a shock absorber. And the shock absorber must do 3 things basically. Reduce the peak force to a low force. Reduce rebound, because rebound is elastic energy, like a trampoline. And thirdly, reduce the mass to the lowest possible. So how do we know your design is performing well? We are going to put it to a test. So we are performing what we call a standard drop test. We want to measure the peak force, we want to measure the rebound, we also want to measure your mass. You will see this in slow motion. You can speed it crush very slowly. And you can see the mechanism of the deformation happening. And you see why it's not working or why it's working very well. So you have one chance to test a prototype and then you develop a next prototype and then you'll be graded on the second prototype or the final prototype.
For our trial, we basically cut aluminum cans and then put it on top of the sponges to act like a spring. And then the mistake was that it did act like a spring and then the rebound was a lot.
We thought of implementing current real-world solutions such as using a sort of sandpit. So we feel that this kind of ideas really help add to the overall effectiveness of our prototype.
The shock absorber thing, it was something that we kind of felt prepared for because it's something like we have kind of like tried something similar before. And I think thanks to like the support of like our teacher, we felt really like well supported and well prepared for the challenge.
I hope that you all think about it scientifically, think about how crushing takes place, how energy is absorbed, and try to reduce the mass.
Our whole design was based around the sponges because it was the first thing we made and then we thought, just upgrade it. We didn't talk about getting rid of the sponges.
For most of it, we are using a lot of our intuition. We didn't really have that many appropriate formulas to apply. But I think our intuition was already relatively strong, so I think we were still able to make quite a decent prototype.
We changed several things throughout the course of our construction. For instance, we changed the pyramid structure to something that would not be too sturdy and just transfer energy without dissipating it.
Well done, students. They've spent the past 2 hours building their energy absorbers, and while the absorbers were crushed in the test, their hopes were surely not. They've got a little bit of time to make adjustments and decide which materials should stay or go. And coming up in just a bit, we'll put their final prototypes to the test. We'll see you in just a while. Welcome back to the National STEM Championship. Now, Raffles Girls' School, St. Joseph's Institution and Sin Secondary School will go head-to-head to design the best energy absorber. Now, it's time for their snazzy 3-minute presentations, starting with St. Joseph's Institution. Good luck, guys.
Here we have a man driving peacefully on a normal day. However, he is met with a car crash and boom, everything flies out and he dies. What could have prevented this?
SJI did pretty well in terms of entertaining presentation.
We had 2 prototypes. And the first prototype is sort of like a box. It's sort of like a sandwich. So how this worked was we had a piece of wood, and then so the wood would act as if like the carbon fiber. It is like the hard surface. So what we did was we tried to alternate between softer materials so that when the pressure is exerted, it will be able to crush and absorb the energy that is exerted on it.
On our final prototype, we have similar concept, but we removed the aluminum cans and we add on another special part that's like an airbag.
Notice you have these wires poking holes into the airbag. What is the principle of these holes in the absorption mechanism?
When we were first constructing it, we noticed that it was too high pressure. So we tried to put those metal wire that pokes inside to the balloon. So when the weight falls on it and then tries to push the air, this air trying to force itself out will push on the metal wire, and this would then open up a hole inside the plastic bag and allow it to dissipate the air inside out.
I like the SGI design. They did pretty well, especially in this airbag concept, and they put in a lot of innovative solutions.
The design is from the bottom, we actually wrap the wood with bubble wrap and then we paste aluminium foil that is folded into like ball shape. And then we put the sponge in the middle and then we repeat the same bottom part as the top part too.
Simin did rather well. They alternated different materials and they used scientific concepts in order to absorb the most energy.
I realized that you have used aluminum foil. You make them into round balls. That's an excellent idea because aluminum, when it collapses, it absorbs energy and doesn't rebound. It just flattens. So this is really a good energy absorption material.
Is there any reason for your order of layering?
We were thinking if like 2 cars hit into each other, we wouldn't want to have just only one car to have the protection. We want to have balance between both cars so they would equally spread the force.
So you are looking at symmetry on both sides.
Yeah.
They did well in terms of their weight, and the impact force was also moderately quite good. But I think where they could have improved, I mean, they do have the idea of this using the aluminum air foam, but it would be better if they have more of this foam evenly distributed to really absorb the impact.
A tree, I'm gonna crash. Wait, no, please, I have no shock absorber. Please, someone help me. Freeze! Are you a car that is gonna crash into a tree? Never fear, because RJS is here.
They excelled in their presentation, but also I found their scientific knowledge was on the dot. They were able to explain the science behind their choices.
First, we have the balsa wood, which is just to ensure that the shock is like spread out equally. After that, we have the triangle structures made out from the straws.
What I do like about RGS is that they have this triangle structure, which helps in terms of impact, where it spreads the force laterally.
What is the math formula? If you know a force and you know the amount it reflects.
The absorbed energy of the shock absorber and then divided by the initial total energy, and then we times it by 100% and we calculate what that value will be. When the judges asked us about the math formulas, honestly, we were a bit flabbergasted. We were staring at each other and we were like trying to recall all the laws of conservation of energy that we learned in class. When we were doing the structure, we focused a lot on like common sense and like, intuition and all our past experiences with building structures, instead of actually focusing a lot on the mathematical physics behind the theory of how the structures would work.
As for the results, I think we all have a few regrets, a few things we'd like to change. But on the whole, I think it's been a very, very positive experience.
I would say we have nothing much to regret today. I think that it helps us to learn a lot and to improve on what we can do in the future.
We really tried our best, so we can go home happy knowing that we really tried our best, yeah.
Yes, you guys did indeed give it your best shot, but the question is, what goes into the best energy absorber? Teams were judged based on technical performance like lowest peak impact force, lowest rebound height, and lowest mass. So without further ado, let's take a look at who's moving on to the Grand Finals. Congrats to Raffles Girls' School for progressing to the Grand Finals. All three teams, give yourselves a pat on the back. And now, it's time for Semi-Finals 4. Just a quick recap, teams will be awarded points based on their performance in these challenges, and only the team with the highest overall score will move on to the Grand Finals. The question is, who is going to proceed? Let's now meet the teams who will be competing at Rolls-Royce Singapore Hub. Put your hands together for Anglo-Chinese School Independent, Bukit Panjang Government High School, and Raffles Institution.
Welcome to the Rolls-Royce site on the Seletar Aerospace Park. I'm Raj, Team Lead for Technology in Services Engineering. We here in Rolls-Royce pioneer the technologies for driving propulsion for land, air, and sea transport. And these technologies are not only sustainable, but also safe. Technological breakthroughs like electrification of flight, these things are a step change that will change not only the way we travel in the future, but also have a very significant impact on our carbon footprint. So we partner both with Boeing and Airbus. Those are our two main customers for the civil large engines. These are the two engines that is solely for their aircrafts. I hope you guys enjoyed the site today and get inspired by it, and all the best for your challenge.
Hi everyone, I'm Vicky and I'm a manufacturing engineer with Rolls-Royce. Today you'll be using the Rolls-Royce STEM kit to build a land-based electrical power-driven model to compete in a time race on this designated course. Your model must be able to travel autonomously and reach the end point within the shortest time. They are being tested on their coding skills, their model design skills, also test a bit of their knowledge of electrical circuits and mainly the different kinds of programming knowledge in getting the car to avoid obstacles and stop at the end point. You will also be required to explain how you will adapt your model to become an autonomous electrical vertical takeoff and landing vehicle to complete a takeoff and landing flight course. If you have any questions, you can ask your mentors later.
How are we presenting our code in the presentation?
Yeah, so you can write your concept, your idea on the flip chart.
We predicted that the challenge would be somewhat related to planes, so we were quite taken aback when we found out that the challenge was something to do with cars.
No, that's not how it starts into us. Okay, label IMU propeller, then put the propulsion sitting inside.
We were kind of expecting the challenge because it's the STEM program, but coding and building cars isn't really our forte. We are really good if it's theoretical bio or chemistry.
We try to actually read the menu and then we try to figure out whether there's any hints inside the booklet which can actually help us with our coding.
Proximity sensor. Yeah, I know. So that's one of the sensors there which we do not know. How do we make sure it doesn't hit into the obstacles? Propulsion is the wheels.
Yeah, just explain energy first, okay? Because like this is very confusing.
Are you able to go and test out the robot and then adjust the values accordingly?
Stop. No, it's not stopping.
Yeah, so I'm an evil mastermind and I'm trying to build this stuff so
it should be like
okay,
Well done, students. Now, why the need to figure out the most efficient way to get from point A to B? That's because aviation and other transport sectors are constantly trying to reduce the environmental impact of travel. And here are some of the key points: being engine efficient, using sustainable fuel, and also electrification. But will their models perform? We'll find out after the break. Welcome back to the National STEM Championship. Now, the spotlight is currently on Anglo-Chinese School Independent, Bukit Panjang Government High School, and Raffles Institution. Now, they spent the past hour and a half building their models and hoping that it will travel efficiently from point A to B. But beware, it is full of twists and turns. How will they perform? Let's find out.
The first plan was the best to have the sensors like tell the car when to steer and how much to steer. When all else fails, just have the motors run continuously and let the car try to force its way around the track.
Although their sensors are not working, they did not give up. They used the brute force method to force their car forward, and that really impresses me.
They don't actually understand how all the sensors work, because they build all the sensors at one go and they just think that it can actually go through. But in fact, during engineering work, we like to start from the small solution into the big solution. So instead, I would recommend the team to put some sensor, test it, it's okay, then we build more sensors. And eventually, it will become a bigger solution.
For our eVTOL design, we just wanted to adapt it based from the car. And so what we have is the body here, the main chassis. And it will be powered by these propellers here, the ducted fan.
They're very clear and their charts explains their analogy, their theory, and distilling it to very simple level for laymen to understand.
We have our motors on the first layer and like a post to ensure the structural stability. And then on top, we have our microcontroller and the other sensors.
They described how they actually use 2 layers to be able to house some of the wiring so it doesn't get in the way. So in terms of design, I thought that they exhibited quite a bit of creativity.
I think we communicated well throughout the whole experiment, and we were able to think on our feet and find like a backup solution when our first solution didn't work out.
In the room when we were actually building it didn't work multiple times, but before presenting it, it worked once, and then we were quite happy. And we came here and it worked, but only one wheel, so it's quite sad.
I can see a lot of hard work put in their product, and maybe it's a lack of time and lack of familiarity with the subject matter that they are unable to deliver in the end.
In the previous round, we had the same difficulties. We had to build a car and code it. We are not really strong in this part of the category of STEM.
Obviously, this is now all theoretical because the practical, it didn't go quite so well, kind of unfortunate. We just wanted to explain this. When the car moves, it has an acceleration, and then the car has a mass. Then this together will be like Newton's second law. And then since the car had a force and move forward a distance, then that's the work done of the car.
I know it can be frustrating when the theory doesn't really translate into practical. So maybe you can describe to us sort of your journey, some of the troubleshooting that you did.
Yeah, we didn't have much understanding of how to go around connecting the circuit to the motors, how to connecting we didn't code in the proper input, output, and other parts. And because our time management was really bad.
Yeah, so I like to say our programming isn't the best. So.
For some things that my team did well, I would say that they had a good initial planning, and I think that they had an overall good presentation, well thought out points.
In the use of the proximity sensor at the very front, I think that collided with some of the other sensors at the side, so it contradicted the direction that the car was moving or stopping. And that's why in the beginning that buzzers kept sounding.
it kept like crashing and stopping and beeping. But we discovered that when the sensor detected when it was close to the wall, it reacted too slowly and couldn't turn in time to avoid the wall. So that's why the front sensor sounded the beeper.
We noticed that R used two proximity sensors. Actually, they could have replaced the center proximity sensors with either an ultrasonic sensor or a light sensor, which they could have used to activate the parking mode at the end.
They realized that they need to vary the sensitivity and the distance between the detection of the obstruction. So they managed to tweak it such that their car moved about halfway through the circuit. So I think they are very impressive in terms of understanding of the STEM technology.
I feel that we could have done better because the model we built made it almost all the way, and with a bit of improvement we could have gone a lot further. Then for the actual presentation itself, I think all of us did our parts very well and the presentation went very smoothly. So all in all, it's not a bad effort from all of us, and I think we are quite happy about it.
The system is connected all properly. The only thing that needs to change really is the sensitivity, the threshold of the sensors. So basically now that I reduced the threshold, right, you can see that it's going to react faster to the obstacles. Having it being more responsive will allow it to basically avoid the obstacles and ideally bring us all the way to the finishing line.
A big congratulations to our 3 teams. Now let's find out who's moving on to the Grand Finals. Raffles Institution. Give yourselves a hearty high five for making it through today's challenge. And well done, Raffles Institution. You will be joining Raffles Girls' School in the Grand Finals.
Thank you.
Thank you.
Thank you.
And that's it for our semi-finals. Next week, our top 4 schools meet face-to-face in a fresh new set of challenges. Who will win the coveted National STEM Championship? You got to tune in to find out. In the meantime, I'm Sonia Chu. Good night.
We will show how we will infiltrate the enemy base. Hee 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 ho.
You guys are my minions.
So this is also energy story.
How was it versus?